National Electrical Code Article 110.26b states that enclosures for electrical equipment shall be designed and installed so as to minimize the possibility of contact with water. Article 409.2 requires that motor starters be enclosed in NEC-12 type enclosure or better. NFPA 70E Standard for Electrical Safety in the Workplace Section 130.3 states that energized electrical equipment shall not be installed overhead where it may be subjected to contact by persons. While there is no specific code reference that prohibits a window above a control panel, the intent of the National Electrical Code and NFPA 70 is to minimize the risk of contact with energized electrical equipment. Installing an electrical enclosure below a window that allows water penetration or access to energized components would violate these codes. Therefore, it is not advisable to install the NEC-12 enclosure below the window, even if the window is fixed and does not allow opening. The National Electrical Code, or NEC, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. It is not a federal law, but rather a set of guidelines developed by the National Fire Protection Association, or NFPA. However, many states and local jurisdictions adopt the NEC as law, making it a crucial reference for electricians, engineers, and anyone involved in electrical work. The primary goal of the NEC is to protect people and property from electrical hazards. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years to reflect new technologies and safety practices. Article 110 within the NEC addresses the general requirements for electrical installations. This article sets the stage for safe and reliable electrical systems by outlining essential considerations for working space access and protection. Article 110.26 specifically focuses on spaces about electrical equipment, emphasizing the importance of providing adequate room for safe operation and maintenance. It details requirements for working clearances, ensuring that electricians and technicians have enough space to perform their tasks without being exposed to hazards. These clearances vary depending on the voltage of the equipment and the presence of grounded objects. Article 110.26 covers the dimensions of working space, specifying the minimum depth, width, and height required in front of electrical equipment. These dimensions are designed to provide enough room for a person to safely work on the equipment while wearing personal protective equipment, or PPE. The required depth increases with voltage levels, reflecting the greater potential hazards associated with higher voltages. Article 110.26b addresses the need to protect electrical equipment from physical damage and exposure to water. Electrical enclosures must be designed and installed to minimize the possibility of contact with water, whether from rain, condensation, or other sources. This is crucial for preventing corrosion, short circuits, and other electrical failures. The NEC also requires that electrical equipment be protected from physical damage, such as impacts from vehicles or falling objects. Article 110.26c discusses access and working space, ensuring that qualified personnel can easily and safely reach electrical equipment for inspection, maintenance, and repairs. The NEC prohibits the use of working space for storage or other purposes that could obstruct access to the equipment. Clear and unobstructed access is essential for quickly addressing electrical problems and preventing potential hazard. Article 409 of the NEC focuses specifically on industrial control panels. These panels are commonly used in manufacturing facilities, commercial buildings, and other industrial settings to control machinery, processes, and equipment. Article 409 provides requirements for the design, construction, and installation of industrial control panels, ensuring their safe and reliable operation. Article 409.2 defines an industrial control panel as an assembly of two or more power circuit components, control circuit components, or any combination thereof. These components may include motor starters, contactors, circuit breakers, fuses, relays, and other devices used to control and protect electrical equipment. The definition is broad enough to cover a wide range of control panel configurations, from simple motor starters to complex automation systems. Article 409.2 also addresses the enclosure requirements for industrial control panels. It requires that control panels be enclosed in a suitable enclosure to protect the components from environmental factors such as dust, moisture, and physical damage. The type of enclosure required depends on the location and application of the control panel. For example, a control panel installed in a wet or dusty environment would require a NEMA 4 or NEMA 12 enclosure, respectively. Article 409.2 further specifies that motor starters be enclosed in a NEMA 12 type enclosure or better. NEMA, which stands for National Electrical Manufacturers Association, defines standards for the design and performance of electrical enclosures. A NEMA 12 enclosure is designed to provide protection against dust, falling dirt, and dripping non-corrosive liquids. This type of enclosure is commonly used in indoor industrial environments where these conditions are present. In some cases, a NEMA 4 enclosure may be required. A NEMA 4 enclosure provides protection against splashing water, hose-directed water, and the ingress of solid foreign objects. This type of enclosure is often used in outdoor applications or in areas where equipment is routinely washed down. NFPA 70E, Standard for Electrical Safety in the Workplace, is a comprehensive standard that focuses on protecting workers from electrical hazards. Unlike the NEC, which primarily addresses the safe installation of electrical equipment, NFPA 70E focuses on safe work practices and procedures for employees who work on or near energized electrical equipment. NFPA 70E is widely recognized as the industry standard for electrical safety in the workplace. Section 130 of NFPA 70E covers the requirements for working on or near energized electrical equipment. This section outlines the steps that employers and employees must take to identify hazards, assess risks, and implement appropriate safety controls. The goal of Section 130 is to minimize the risk of electric shock, arc flash, and other electrical injuries. Section 130.3 specifically addresses the placement of energized electrical equipment. It states that energized electrical equipment shall not be installed overhead where it may be subjected to contact by persons. This requirement is intended to prevent workers from accidentally contacting energized parts while performing tasks near the equipment. The term overhead is not explicitly defined in NFPA 70E, but it generally refers to equipment that is located above head height. This could include equipment mounted on ceilings, walls, or other elevated structures. The intent of Section 130.3 is to ensure that workers are not exposed to unnecessary electrical hazards while performing their duties. The placement of electrical equipment below a window raises several safety concerns. Firstly, there is the risk of water intrusion. Even a fixed window may not be completely watertight, especially over time. Cracks, gaps, or sealant failures can allow water to penetrate the building and drip onto the electrical enclosure below. Water is a conductor of electricity, and contact with energized components can create a shock hazard or cause equipment failure. Secondly, there is the risk of condensation. Changes in temperature and humidity can cause condensation to form on the inside of the window, which can then drip onto the electrical enclosure. Condensation can be particularly problematic in areas with high humidity or large temperature swings. Thirdly, there is the risk of accidental contact. While the window may be fixed, there is still a possibility that someone could accidentally break the window and come into contact with energized components inside the enclosure. This risk is greater in areas where there is a lot of foot traffic or where the window is exposed to potential impacts. Given these safety concerns, it is generally not advisable to install a NEMA 12 enclosure below a window, even if the window is fixed and does not allow opening. The risk of water intrusion, condensation, and accidental contact outweighs any potential benefits. There are several alternative solutions that can be considered. Firstly, the electrical enclosure could be relocated to a different location where it is not exposed to water or other hazards. This may involve moving the enclosure to a different wall or to a separate room. Secondly, the window could be replaced with a solid wall. This would eliminate the risk of water intrusion and accidental contact. However, this may not be feasible if the window is needed for natural light or ventilation. Thirdly, a drip shield could be installed above the electrical enclosure to deflect any water that may drip from the window. A drip shield is a simple and cost-effective solution that can provide an extra layer of protection against water intrusion. A drip shield should be made of a non-conductive material and should be large enough to cover the entire top surface of the enclosure. Fourthly, an NEC enclosure could be used instead of an NEC enclosure. A NEC enclosure provides greater protection against water and other environmental factors. However, NEC enclosures are typically more expensive than NEC enclosures. Fifthly, regular inspections and maintenance should be performed to ensure that the window is in good condition and that there are no signs of water intrusion. Any cracks, gaps, or sealant failures should be repaired promptly. In addition, the inside of the enclosure should be inspected regularly for signs of condensation or corrosion. By taking these precautions, it is possible to minimize the risk of electrical hazards and ensure the safe and reliable operation of the electrical enclosure. In summary, while there is no specific code reference that prohibits a window above a control panel, the intent of the NEC and NFPA 70E is to minimize the risk of contact with energized electrical equipment. Installing an electrical enclosure below a window that allows water penetration or access to energized components would violate these codes. Therefore, it is not advisable to install the NEC enclosure below the window, even if the window is fixed and does not allow opening. It is important to consider the potential risks and implement appropriate safety measures to protect workers and equipment from electrical hazards.